So a quick recap. When we are looking at NPR or permutations, it's really important to remember that order matters. So it really matters what order things happen in. So if we're placing tiles down on Scrabble, it really matters what order these tiles are put in so that they actually spell a word. For the fundamental counting principle, it matters what order they are in. If we're putting together an outfit of pants, shirts, and socks, it's important that the pants go in the pants slot, and shirts go in the shirt slot, and socks go in the sock slot. Okay, so order matters. When order doesn't matter, you're looking at something called combinations. For example, if we're just picking up tiles to put on our Scrabble board, it doesn't matter what order you pick them up. You can use them. If you got an A to be your first tile or a T to be your last tile, it doesn't matter which order you got it in. You can use it at any time. Also, if you're picking teammates for a basketball game, let's say you're doing a 3-on-3 game and you pick two people, it doesn't matter what order you pick those two people as long as you pick those two people. That would contradict if we were picking someone for president, vice president, and secretary. That would matter what order you had them in, because that person you pick for president needs to be in the president's spot, and so on. So order doesn't matter. We use something called combinations. And so if you're trying to figure out, are there going to be more or fewer than permutations? Remember, if order doesn't matter, you have all kinds of ways this can go. I mean, if order matters, ABC can be BAC, can be CAB, whoops, or ACB, I suppose, CAB. Oh, what else am I missing? BCA, and it can also be CBA. Okay, but that's if order matters. If order doesn't matter, ABC is the same thing as CBA. Those are the same thing. It's the same thing as BAC. That's the same thing. So really, as long as I have the letters ABC, there's only one way to do that compared to 6 ways to do it if order does matter. So there's going to be fewer ways with combinations than there are with permutations. So with combinations, here's what's happening. You still have N for the number of choices and R for the number of events. But what's going to change is you're going to have N factorial on top and N minus R factorial on bottom, but then you also have another R factorial. By the way, NCR can also be written like this, where you have your parentheses, but notice there's no fraction bar. It's an N on top and an R on bottom. It means the exact same thing. So let's look at page 708, example 1. What example 1 says is, a standard deck of 52 cards has 4 suits with 13 different cards in each suit. You kind of already knew this. Of the hearts, you have 13 cards, and of the diamonds, you have 13 cards. The clubs and clovers each have 13 cards, and altogether there's 4 of those. So if the order in which the cards are dealt is not important, which is typical for a card game, it doesn't matter what order you get those cards in, how many different 5-card hands are possible? So what we're doing is we're saying, well, we have 52 cards total, but we only care about 5 of them. How many different 5-card hands are there? So if we use our formula, it's going to be 52 factorial on top over, and then 52 minus 5 factorial times 5 factorial. So that is 52 factorial over 47 factorial times 5 factorial. And if we actually wrote that out, I'm not going to write out 52 factorial. But here's the idea. There's 47 factorial on bottom, so that's going to cancel out. So I only need to write 52 factorial out until I get to 47. Now I can stop, because once I get to 47, that's all going to cancel with the 47 factorial on bottom. And then I still have 5 times 4 times 3 times 2 times 1. And then these are going to cancel out with various ones on top, and my whole answer is 2,598,960 ways that this can happen. Okay, another example would be, and this isn't in the book, but if you have a 52 card deck, if the order is not important, how many different 7-card hands are possible? So once again, I've got 52, choose, we'll use the word choose for the C, 7. So now it's going to be 52 factorial over 55 factorial times 7 factorial, and if we work that all out, we get 133,784,560. So there's more ways to do that.